pay attention please. We're going on to the second method for solving simultaneous equations. This here is the substitution method. Sorry, can you concentrate here please? You only use this method, the substitution method, when you have one of the equations where one of the letters is by itself. So you can see you've got y equals, one of the equations has got x and y on the same side, but there's one where one of the letters on the by itself. So that's when I would use substitution method, when one of the equations already has one of the letters by itself. Okay, the first thing we do is we label the equations. So I'm going to call this number 1 and number 2. I put them in circles. I try and use a different colour, that way I don't get it mixed up with the other numbers. Alright, now the secret to this method is finding the equation where one of the letters is by itself. So on equation number 2 here, you can see it says y equals x take 4. Yep. And if these two equations are going to be equal at a point, like our graphs yesterday, they cross at one point, then I can substitute for y in the other equation. Wherever I see y, instead of writing y, I'm now going to write x take 4. Because they've got to be equal. So if y is equal to x take 4, then it must be true up here as well for both equations. So if you write this down, the first thing we're going to substitute, so let's use the word sub and abbreviate it. I'm going to substitute equation 2 into equation 1. This is the tricky bit. This one you really got to concentrate here. I'm going to do two examples. I'm going to do this example, then I'm going to do one of the first ones from the sheet. I'm going to substitute equation 2 into equation 1. So here's equation 1, and what I'm going to substitute in, the thing I'm actually going to substitute is y is going to be equal to x take 4. So where I see y in the second equation, in equation 1, I'm not going to write y anymore. I'm going to write in its place. The word substitute means replace, doesn't it? In its place, I'm going to write x take 4. So equation 1 is going to become x, doesn't change, minus 3 times y. So it's 3, I'm not going to write y, I'm going to have 3 times this. In maths, we put things in brackets when we want to multiply, don't we, expression, equals 16. This is the crux to this method. You have a look there. The original equation was x take 3y equals 16. Now have a look here. I've got x take 3 times what y is from the other equation equals 16. So people understand that step? That's the substitution method. That's what I've done. I've replaced y with x take 4. Where did I get that x take 4 from? From the second equation. Does that make sense to you? Okay, now if you have a look what that substitution's done, it's left me with one equation with only one type of letter in it. Initially we had 2 different types of letters in the present. Alright, so now we've done equations like this before. We get rid of the brackets first, so this becomes x take, negative 3 times x is negative 3x, negative 3 times negative 4 makes plus 12, be careful about your multiplying signs, is equal to 16. This equation belongs to the group where we said the unknown appears more than once. A method for solving those equations, who can remember? What is that method for solving the unknown appears more than once? Jacob?
Is that when you make it 0? No, that's not the one.
No, that's not the one. Sarah?
Was it x to the left, numbers to the right?
X to the left, numbers to the right. Everyone remember that one? Okay. The x is already on my left here, but what's the thing that needs to be moved? The plus 12. So how do I get rid of plus 12?
Minus 12.
Take 12 from both sides. These two are left here. What's x take 3x make? Negative 2x. I take the 12s away. Equals 16 take 12 is 4. I've got negative 2x. So that's multiplying. So I divide both sides by negative 2. Yep. That gives me x equals negative 2. 4 divided by negative 2 is negative 2. Right, so our answer at the moment is it's 2 something or other, isn't it? I've got the x value where the point where these two graphs are going to cross. I now need to find the y value. I've got 2 choices. I can put this number back into this equation, this one. Which one do you think is going to be easy to find the value of y? Put it into this one or this one? Back into the one where the y is already by itself. So the next step I'll write down is I'll say I'm going to sub x equals -2 in equation 2. Alright, so I'm just writing down the steps of how I'm doing things so it's easy to follow. If you set it out like this, you won't make many mistakes. Alright, so into this equation is going to come y equals, instead of x, I'm now going to write what? -2, take 4. That gives me the answer y equals -6. Sorry, it's -2. Sorry, it's -2, -6. You might remember yesterday when we were drawing the graphs and finding where they cross, you have to be really accurate with your graphs. Right? And you've got to have nice grid paper, and the grid paper I gave yesterday wasn't fantastic. This method here, don't have to have an accurate piece of grid paper to do it. It's an algebraic method. It's, in the long run, it's quicker as you get better at them. Okay, I'm going to do now the first one off sheet 2. So can you turn to sheet 2? You'll see up the top F, and there's 2 equations there. So I'm writing the 2 equations down. Right, first thing we do, you need to do this in your notes. You can actually do it on the back of that sheet if you want. You need to do about 10, so look at the space you've got. You need to be, maybe draw columns, might be best. Alright, so the first thing I do is label the 2 equations. That's my first step. I label the equations. So you can go to the back of this. Now, I've got 2 equations. This is now also a substitution method 1. Why do I know it's a substitution method 1? How do I recognise that it's a substitution? No, you'll have ones that have 2 equations we can't use substitution. What did I say before allows us to do substitution?
One with y, one with the perennial by itself.
One of the letters by itself. So this has got y equals. The other equation's got x and y together. But to do the substitution method, you need one of the equations to have a letter by itself. In our example over there, equation 2 had the letter by itself. This one's equation 1. It'll change all the time. Is that understood? It could be 1 or 2, doesn't matter. Alright, so I recognise there's a substitution problem because I've got one of the equations has the letter by itself. So that one there is the one I substitute into the other equation. Is that understood? The one that's by itself is the one you substitute. So in this case here, I'm going to substitute equation 1 into equation 2. I'm going to put in this substitution, y equals 2x. After I finish this example, we'll go through the other ones on the sheet and we'll talk about which one would we substitute. Okay, so in equation 2 now, I'm going to write x plus, but I'm not going to write y. What am I going to put in its place? 2x is equal to, right, so you always end up with just one letter in the equation and just have to do the substitution. That's the whole point, to make an equation with just one letter involved. That's what the substitution method thinks. These will be equal when y is equal to 2x. Now I can simplify this. X and 2x makes 3x equals 6. Divide both sides by 3, so I get x is equal to 2. At this point, I've got the answer 2 something, haven't I? So I've got to find the y value. Which equation is going to be easier to find y? The first one or the second one? The first one, probably. Either of them would work. So I would now do sub that answer, sub x equals 2 into equation 1. Would be the easiest one to do. And that means y will equal 2 times 2. Probably best to substitute in brackets so you don't make mistakes. And what's 2 times 2? 4. So my answer that we needed here was 2, 4. So if you look at the grid up the top, I want to show you the answer one. I'll show you this one. If you look at the grid up the top, everywhere you see 2, 4, and it appears 3 times, you put the letter F. 1 on the second row and 2 on the bottom row. Everyone happy with that? Alright. I'm not going to do any more examples because I want you to follow these examples, but I am just going to go through each of the letters now and talk about which one you substitute into which. Alright, so I'm going to go down the left-hand side first. Look at N. You might want to make a little note here. You've got two equations, y equals x take 4 and x plus y equals 6. It's a substitution one. Why is it a substitution problem? There's a letter by itself. Which letter's by itself? And that's the one you substitute in the second equation. Does that make sense? So where you see the second equation, you won't write x plus y, you'll now write x plus x take 4 equals 6. Does that make sense to you? Let's go down to the next one, y. Question y. There it says y equals x take 3. The other equation is x plus y equals 6. Very similar to n, isn't it? No, I'm sorry. I was reading the wrong one. So it's got one of the equations, the letters by itself, the first equation. So then you use that to substitute in the second equation. Yes? Go down to E. You'll have a look at E. Both of those have the y by themselves. So it doesn't matter which one you use. What you'll end up with, if we use the first one, y equals 3x take 7, then in the second equation you just replace the y with 3x take 7. So you'll end up with 3x take 7 equals x take 5. I'll just write that on the board, because you might remember 3x take 7. I'll leave this on the board so you don't have to write it down now. End up with that. People see how I've done that? I'll substitute that y with what the other y equaled. Remember this one, that's got to go over that way, and that's got to go that way, doesn't it? X is to the left, numbers to the right. So you should be able to do that one. Look at you. Who can tell me which equation you'll use to substitute? The top or the second one? The top one will substitute into the second one. Okay, go up to the top of the next side, O. O is a bit like E. You'll see that they've both got y by themselves. So it doesn't matter which one, it'll end up being like that. You'll end up with 2x take 8 equals x take 5. Right, because that one was 3. In T, you've got two equations. Which one we use to substitute? The top will go into the second one, replace the y. In H, you've got y equals 3x plus 5, and you've got x equals y take 5. What do you notice there? I could use either one, couldn't I? So it's up to you which one you want to use. But what you'll have to do in that one, you'll have to get the x's to one side, the numbers to the other side, or the y's to one side, the numbers to the other side. Same approach. S is a very straightforward one because you've got y equals x and y equals 3x plus 4. So it'll be similar to that, but a bit easier. In D, which one will what will I substitute in D? The top one. But what do you notice is different about D? It's x by itself, isn't it? So make sure you put it where x is, not where y is. Does that make sense to you? Substitute for x because x is by itself. And for A is very similar to D. All right.